Hello, good day students, and you're welcome back to my channel. If you're new in this channel, please consider subscribing. In today's lesson, we are going to be talking about complex number. What exactly is complex number? Like I have on the board here, a complex number is defined as a mathematical expression or equation of the form z equal to a plus bi. So in this form now, which is most times referred to as the basic or standard form of a complex number, a means the real part, and B, this part now, which is BI, means the imaginary part. And these are the numerical examples of a complex number. So, a complex number is a mathematical expression of this form, where A is the real part and BI is the imaginary part. So, examples of it are that Z is equal to 3 minus 3i. Number 2, Z is equal to 4 minus 8i. Number 3, Z is equal to 4 minus 4i. And finally, the one I have here, z is equal to 7 plus 8i. So all these you see here are examples of a complex number. But before we move into this deeply, we need to understand what is an imaginary number. Yes, we need to understand the concept of imaginary number. What exactly is an imaginary number? Well, imaginary number is simply a number that cannot be plotted on a real number line. For instance, if I have a number line like this, such that this is, here is 0, here is 1, 2, 3, 4, and so on, and here is minus 1, minus 2, minus 3, minus 4, and so on. So, if this is a number line, from this 0 to the right, or towards the right infinity, it ranges from positive 1 down to positive infinity. Then from this 0 now, down to the left, ranges from negative 1 down to negative infinity. So it therefore means that on this number line, no imaginary number can be there. So imaginary numbers are those numbers that are being imagined to have been in existence, but in reality, they are not really in existence. And again, this concept of imaginary number also arose as a result of the square root of minus 1 cannot exist. So if you press on a non-fancy calculator, if you use a non-fancy calculator and press this square root of minus 1, it will give you indeterminate or mathematics error. Alright, so it means that this square root of minus 1 does not exist. So because of that, mathematician now give it a symbol I. And this symbol I means imaginary number. It means that this square root of minus 1 is being imagined to be in existence, but in reality, it does not exist. So because of that, wherever we see square root of minus 1, it means imaginary. Alright? And again, it's not just enough to say that square root of minus 1 does not exist, but square root of negative any number does not exist. Say square root of minus 9, alright, does not exist. That is in a non-fancy calculator now. And square root of maybe minus 4 is also math error. But since square root of minus 1 is equal to I, we can now say that square root of minus 9 is equal to square root of 9 times square root of minus 1. According to solve, we can have something like this. And therefore, this is equal to 3 times I. Hence, we have 3I. Alright? And as for this, since square root of minus 1 is equal to I, we can also say from here now that square root of minus 4 is equal to square root of 4 times square root of minus 1, which will give us nothing but 2 times I, which is 2I. So in the whole thing, whenever we see I simply means square root of minus 1. Okay, let me also from here and do something. So if square root of minus 1 is equal to I, it therefore means that I can square both sides. And when I square both sides, I'm going to have that square root of minus 1 all squared is equal to I squared. So this is it now. So let me just enclose. So therefore means that this which I have here, I actually squared both sides, and I have square root of minus 1 all squared is equal to I squared. So according to mathematics, this square can cancel this square root such that minus 1 will be equal to I squared. So two important things we need to have in mind. Whenever in complex number we see square root of minus 1, it simply means I. And wherever we see minus 1, it simply means I squared. Therefore, we can say that I squared is equal to minus 1. So it is very important to take note of that, because we are going to be seeing, or we are going to be making use of this to solve many problems in complex number. Okay. So what I wanted to say about imaginary number, like I said, imaginary numbers are those numbers that are imagined to be in existence, but in real sense, they are not really in existence. So now, for us now to derive a complex number from imaginary number, imaginary number, whenever they are being attached to a real number, either by addition or subtraction, what we are going to have, or the outcome of it, will be a complex number. For instance, we gave these things to be examples of a complex number. And you can now comfortably see that this minus 3i is an imaginary number. So this minus 3i is actually attached to this real number 3 by means of subtraction. And therefore, this attachment now has resulted the whole of this 3i and minus 3i to be a complex number. And again, this imaginary number now, minus 8i, being attached to this real number 4, has made all of them a complex number. So what I'm trying to say is that whenever an imaginary number is being attached to a real number, either by addition or subtraction, the whole result is called a complex number. Again, this plus 8i is an imaginary number, and it is being attached to this real number 7 by means of addition. So the whole outcome is a complex number. So a complex number is a combination of a real number and an imaginary number. Alright, such that the part that is void of I is called the real part, and the part that has I is called the imaginary part. Okay, very quickly, there's also another concept I want us to see as far as this concept of complex number is concerned. Alright, we call it conjugate of a complex number. Conjugate of a complex number. So what exactly is conjugate of a complex number? Whenever we hear conjugate of a complex number, it is just very simple. A conjugate of a complex number is simply a complex number obtained by simply changing the sign of the imaginary part. Let me take it again. A conjugate of a complex number is a complex number obtained by changing the sign of the imaginary part. Alright? So now, having said that, if you look at this complex number, for instance, this is a complex number 1, so it is 3 minus 3i. So the imaginary part is this minus 3i. So if I change this sign of the imaginary part, which is minus, if I change it from minus to plus, the whole thing will now be a conjugate of this. Alright? And again, this second one now, if I change this minus here to plus, what I will have will be a conjugate of this, which is here. So if whenever you change the sign of the imaginary part of a complex number, what you are going to have will be a conjugate of the initial complex number. Alright, so having said that, I'm going to write out the conjugates of all of these complex numbers here. Alright, so let me make a table. Complex number and their conjugates. So the first one, which is z equal to 3 minus 3i, this is the complex number. So its conjugate will be that z bar will be equal to 3 plus 3i. Now notice one thing again, that bar, that is whenever you write z and you put a bar on top of it, that symbol is used to know that this is actually a conjugate of a particular complex number. Alright, so the second one, which is what, 4 minus 8i, z is equal to 4 minus 8i. This conjugate, which is z bar, will be equal to 4 plus 8i. The next one, which is the third one is z equal to 4 minus 4i. This conjugate z bar will be equal to 4 plus 4i. Lastly, the fourth one I have here says that z is equal to 7 plus 8i. This conjugate z bar will be equal to 7 minus 8i. So it is as simple as this. So the whole idea about complex number and its conjugate is that its conjugate is actually obtained by simply changing the sign of the imaginary part of that initial complex number. Very, very important. So the next concept we are going to be entering now very shortly is nothing but algebraic expression of complex number. Alright, and by this algebraic expression of complex number, I mean addition of complex number, subtraction of complex number, multiplication of complex number, and finally division of complex number. So stay tuned.